9.3 constant acceleration formula 1. We will consider a journey of a particle. So the initial velocity is u, and this particle move along a line. Let's say displacement is s. So u is initial velocity, and assume that t is the time it takes to come to this s distance, the displacement, or this is v, velocity after t seconds. After t seconds. So t is the time. So s is the displacement or journey. And assume this one travel to here with the constant acceleration. A is the constant acceleration. Then I can draw this graph like this. Start velocity is u and go with a, and the finishing velocity, the after t second, this is the velocity. Now a is the gradient. A is the gradient. So what is the gradient now? So this distance is v minus u. So whole distance is v, whole is v, and up to here u. This is v minus u, and this is t, because this is t. And so a equal acceleration equal gradient. So acceleration is gradient. So acceleration is gradient y divided by x. So v minus u divided by t. So I will cross multiply by this one. So this is going to be at v minus u. I'll bring to u here. So v equal u plus at. So I'll rewrite the other way. So v equal u plus at. So this is a one equation we can use. So the time, acceleration, and two velocities, initial velocity and the velocity after t seconds, if you know this is t. So we can use this as a formula. So the other one, this area is S is the displacement. So displacement is area. So S is, what is the area? This is a trapezium. So this is half a times. This is u, and this height is v times t. This is the first formula, and the second formula so far we can use for the calculations. Example 4. A cyclist traveling along a line, straight line, and she accelerates at the constant rate from the velocity 4 So the starting point, so velocity is 4 ms minus 1, and after 40 seconds, it's become 75 ms minus 1. So a is a constant, called a constant acceleration. Now the first question is the distance travel. Let's say s, this is for the seconds. So distance travel is, now we have u plus v divided by 2, or half. This is same as half u plus v times t. Half u plus v times t, all this is same. So we know that u is 4 and v is 7.5, and times 40 divided by 2. So 7.5, 11.5 multiplied by 20. This is going to be 230, 11.5, 230 meter. And part B, her acceleration in the 40 second. The other equation we equal u plus at. So in other way, we know that a is v minus u divided by t. I'll bring this one divided by t. So v is 7.5 minus u is 4 divided by t is 40. So this is going to be 3.5 divided by 40. So this is 0.0875 ms minus 2. Now the same sum you can work with the graph, but it is easy now to work with. So starting from here, starting is 4, then go to 7.5, and yes, that's all basically. This distance is 40 seconds, and we need to find the area. So distance travel, this is the area. So area is half this trapezium 4 plus 7.5 times the perpendicular height now, because this is the parallel lines, 40. This is the same thing. And now we need to find a acceleration. Acceleration is the gradient of vt graph. So gradient, so we can find what is y divided by this, let's say a, and this is b. No, sorry, we'll take different letters, m, and this is n. So m divided by n, m means 7.5 minus for that distance, and this n is 40, which is 0.0875 ms minus 2. So now it is easy to work with this equation. What you usually do, we will match with, because from my equation we can only find one unknown. So we will see that the availability is given. So we know u is 4, v is 7.5, and a we don't know. Then t is we know, that is 40, and S we don't know. Now we have two equation in hands. One is V equal U plus 80, other one is equal U plus V divided by 2 times T. So if I need the distance, so I can see that this I know U, I know V, and I know T. Yes, that can be done. Then I need the acceleration. So I know V, yes, I know U. Then do I know T? Yes, yeah, done. That's it. So we have the data in hand and we match with the equation. Example 5. A particle move a straight line from A to B. So A to B, it's moving with the constant deceleration. So deceleration means negative acceleration with 1.5 ms minus 2. The velocity of particle at A. So A, the first initial velocity is 8. And particle at B, it is 2 ms minus 2. Find the time taken to the particle. So A, we don't know S and we don't know T. Okay, first of all, time. We have two equation in our hand. V equal U plus AT, S equal U plus V over 2 divided by times T. Okay, V is given, U is given, A is given, we can find. So let's consider V equal U plus AT, then V is 2 and U is 8 and plus A is minus 1.5 and T. So this is 2 equal 8 minus 1.5 T. So 1.5 T equal 8 minus 2. So this is going to be 6 equal 1 point times T. T equal 6 divided by 1.5. 6 divided by 3 over 2. It means 12 over 3 is 4. So that is going to be 4 seconds. And part B, the distance from A to C. So distance is S equal U plus V over 2 times T. You know U is now 8, V is 2 and divide by 2 and T we found out 4. So this is 10 divided by 2, 5 times 4, 20 meter. So second part for sum is so A, B and C. So after B it is continue to move. So this time is 4 seconds up to 6. So this is 2 seconds. So basically from 6 seconds. So this is U equal 8. We need to find T equals 6 and A is still 1.5. So we can put V equal U plus AT. V is, we don't know, U is 8, then minus 1 point times T is 6. So V equal T minus 9, which is minus 1. So this is the positive direction. It means now this one is C mean this will go and 0 and it is in the return journey. Now we need to find the second part, the distance from A to C. So A to C distance. So A to C distance is different. The travel distance, so A to C distance, we can find U plus V over 2 times T. U is given 8 and V is minus 1 and 2 times T is 6. So this is 21 meter. This is ms minus 1. So part C. So total V is minus 1. ms minus 1. It means this is the positive direction. So it is going to the other way around. So if it is this is AB direction. So now they are in the BA direction. That's why it is minus. And D, the total distance from A to C is equal U plus V over T times T. So 8 plus minus 1 over 2 times 6. So this is going to be 21 meter. So make sure you put the minus 1 the right symbol when you apply. Question number 6, example 6. A car moves from a traffic light along a straight road with a constant acceleration. So U equals 0 ms minus 1. A, we don't know. The car starts from the rest of the traffic light and yes, rest it is usually car start from rest if the traffic light 0. The traffic light and 30 seconds later, so T equal 30 seconds later, the car passes a speed trap where it registered as a traveling at 45 km/h. So we have to assume V equal 45 km/h minus 1. This is not SI. So 45 multiplied by 1000 to make it meter. Divide so hours to second 3600. This is going to be 450 over 360. 1 point something. And this is going to be 12.5 ms minus 1. And acceleration of the car. We have two equations in hand. One equal V equal U plus AT. Other one S equal U plus U divided by 2 times T. So acceleration we have U. We don't know A. T is given. So we can find V equal U plus AT. Then A equal V minus U divided by T. V is 12.5 and 0 and T is 30. So 12.5 divided by 30. Yeah, that is going to be 5 over 12 ms minus 2. And part B, find the distance traffic light to a speed trap. So S equal V plus U 2 times T. Then V is 12.5 plus 0. divided by 2 times t is given 30. So times 15 to 15. So this answer is going to be 187.5 meter.